if you had log of a third or log of a half, then the negative graph, log graph, would go in the opposite. So that's the negative, that's the positive. Okay, that's what your log graph will look like. Now the theory, if remember in yesterday's episode, we did the theory of the exponential graphs. Let's quickly go through that theory. We said all standard exponential graphs have only one y-intercept. The x-axis is your asymptote. A positive graph is known as an increasing function. A negative graph is known as a decreasing function. We also said that the domain of this graph is x is an element of real numbers, y, and the range y greater than 0, y is an element of real numbers. So now let's do the theory with regard to the log graph. So the theory with regard to the log graph is that all standard log graphs, point number 1, have only one x-intercept. So there we go. Even if they didn't give you that, say they didn't give you this, and they told you this is a point P, X and Y, and it's a standard log graph. They said determine the coordinates of P, X and Y. Again, like we said, it's a no-brainer. All we're going to do now is we're going to say P, X and Y. The coordinates of P, X and Y is P. All log graphs have only one x-intercept, 1 and 0. Right. Which line here? The y-axis or the x-axis? Which line is your asymptote? Which line will that graph never touch? Your y-axis. So in the exponential graph, your x-axis was the asymptote. In your log graph, your y-axis is your asymptote. And what is the equation of your y-axis, guys? X equals 0. Right. We now have the domain of this graph. What is the domain? Which x values here will give you corresponding y values? Will this graph ever touch y? Will ever touch the y-axis? No. Will it ever go to the negative y? No, it will never. It will only be to the positive side. So we'll say x greater than 0. X is an element of real numbers. What is the range of that graph? Which y values? Any y, because this goes on to positive infinity, this goes on here to negative infinity. So any y value from positive to negative. So we say y is an element of real numbers, or we can say from negative infinity to positive infinity. And that is your standard questions that can be asked on your log function. They might tell you on the same set of axes, draw the inverse function of that log graph. So obviously the inverse function is the exponential, and the exponential will go that way. Where this graph goes through 1 and 0, the exponential will now go through 0 and 1. Okay, where this graph is x equal 2 to the y, the equation of this, so if this is h of minus 1, the inverse function, the equation of that will be 2 to the power x, because your base is 2. So this is the graph log 2x, and that is the graph 2 to the power x. Okay, top one being your exponential, bottom one being your log. Remember, they related. Where exponents ends, logs takes over. They come from the same family, but they are opposite. Okay, so here goes. So this is the log graph. If we wanted to find out, grade 12s, if you wanted to know what is the inverse function, now we're going to be doing inverse functions, right? So now, you know this is a typical grade 12 concept, the inverse function. This has been added to your grade 11 content to make it your grade 12 content. So your inverse function, very two basic rules on there. You swap the x and the y, swap the x and the y, swap x and y, and number 2, make y the subject of your formula. And I'm going to tell you f of x is equal to 2x plus 8. I want the inverse, grade 12, I want the inverse function in the form f of minus 1x equals whatever, for 4 marks.